This is for Lab 7, Activity 1-1 and 1-2, and so all of Investigation 1. This right here is a multimeter. Multimeter is called a multimeter because it can measure multiple things. It can measure voltage, it can measure current. Let's see, current's down here. It can measure, here's that symbol, the omega symbol. It can measure resistance. And some of them can measure other things. We'll see this in the next lab, Lab 8. It can even measure capacitance for this case. So one of the things about a multimeter is that because it can measure so many different things, there are different settings up here, and there are different plugs. So I've got two leads, two wires. The COM is always going to be the black one. Depending on what you're measuring, if you're measuring voltage, you're going to put it here. If you're measuring small amounts of currents, you're going to put it on the milliamp right there. And if you're measuring larger currents, you're going to put it on the capital A. This will measure up to 20 amps of current. So we're not going to be measuring that large, but I'm going to put it on here because it has the biggest fuse in the circuit, and I don't want to break the circuit. So now I have to set my dial. And to set my dial, I'm not measuring voltage. I'm not measuring resistance, I'm measuring current. So I'm going to move it over to current. Now you'll notice that that some of these are in white and some of these are brown. And the ones that are in white have a little squiggly mark over it. That means that's a kind of current that's going back and forth, an oscillating current, and also called alternating current. That's AC. We're measuring direct current. It's just going in one direction, so it has a flat line. So I'm going to move this over. And there are, for the current, that's direct current, it has a 2 little m, 20 little m, 200 little m, and then the 20 with no prefix. This is the one that I've set it for with 20A. If I'm measuring milliamps, I would put it onto one of these. And depending on whether it's a really small current or up to 200 milliamps, I could put it on that one right there. But I'm going to keep it just on the amp setting. And now we're ready to use it in our circuit for Activity 1-1. This is our circuit in figure 7.2a. We've got a double pack, so I've got 3 volts, and these are fresher batteries. We've got from the positive terminal coming out to a single bulb, then we've got a second bulb, and then this one goes back. I haven't hooked it up yet, but I'll hook it up right now so you can see the brightness of the bulbs. There we go, so you can see the bulbs are lit. And our first step is to observe the brightness, and then we're going to put this multimeter connected, as in the middle picture, B. We're going to put our multimeter here inside the pathway. In order to do that, I have to take my multimeter and I have to break this path and put my multimeter inside. So let's do that right now. So here's my multimeter. And I'm going to clip on from the positive terminal going onto my red lead. And then my black lead, I'm just going to use it to be my wire. So now any current that's in the circuit has to, let me lift this up a little bit. Any current that goes in the circuit has to go through the multimeter as if this were like a light bulb. That I've got current coming in through here and then current leaving through here, and that's going to be, we're going to try to observe to see if the brightness of the bulbs changes at all when I touched it here. And it looks like those bulbs, well, I can't remember what they looked like before, but they're lit. They're certainly not super dim or super bright. So that's the middle circuit. I'm going to unclip that and then set up the third circuit. And now we're ready for step 3, and we're going to connect the meter a different way now. I've reconnected the wire to the bulb, and instead of putting my multimeter into the circuit, I'm going to put my multimeter across this bulb. So I'm going to put the lead that's closest to the positive terminal. I'm going to make that my red one. I'm going to touch one here. First I want to connect my circuit so the light bulbs are lit. Okay, so I just connected it there. All right, so I'm going to touch the red one here. I'm going to touch the black one there. I'm going to see if this makes any difference to the circuit that I'm trying to measure. Oh, do you notice that? So when I touched it here, there appears to be a fairly significant change to my circuit when I connect my multimeter across in parallel to light bulb A. Big change. We're going to change our multimeter now for activity 1-2. We had the setting for measuring direct current, but now I want to measure voltage. So I'm going to move it over to the other side. And I've got a squiggly line, that would be for alternating voltage, and I've got a straight line. So because I'm expecting, what did we say that voltage was? About 3 volts. So I put it on the 2, that's not enough. It would be more than that. I'm going to put it over to the setting that's on 20. And that means it can measure up to 20 volts. Okay, but I have to make a change down here because it's still put in the slot for 20 amps, and I'm measuring voltage now. That's a V. So I have to move this plug. I'm going to keep the black one always in the COM. No matter what I'm measuring, I'm going to keep this one in the black. And I'm just going to measure this one around for voltage or for resistance. We'll see that later in the lab. And if I'm measuring small currents here, bigger currents there. Okay, so now pause the video and make your prediction 1-2 at the top of page 132. Here's our original circuit, and we can see the bulbs are lit. I'm going to disconnect that red wire, and I'm going to insert the multimeter into this single pathway right there. So I'm going to put it in series with the one pathway that's there. Okay, so I've disconnected that red wire, and I've connected it to one of the leads of the multimeter. So now it's like one big wire that goes into the multimeter. And then I've got a black wire that comes out of the multimeter that I'm going to connect to here. And we're going to see if we can measure now, see if our circuit changes at all. Okay, so this is set to voltage, and we're going to see, is my circuit, is everything connected? Looks like I've got everything's connected, and that looks like I'm not getting any kind of brightness. All right, I'm going to now connect it the other way, and instead of having it in series, I'm going to put the original circuit, and I'm going to just connect it around, across this first light bulb in parallel to it. Okay, so I put that wire back, and I put my red wire here, and now instead of putting it into the pathway of where the current is, I'm going to just touch it this side so the multimeter is a parallel pathway. Any current has to go through the multimeter and then back to this side. And let's see if this changes the circuit. Oh, it looks like the circuit hasn't been affected that much. So if I'm trying to measure a circuit, if the device that I'm using makes a big change, then I'm measuring a different circuit. So whenever I'm using my multimeter to measure a circuit, if there's light bulbs, it's fairly easy to see. But if I don't have any light bulbs there, it's not clear whether or not I'm changing the current that's already in the circuit. And if I'm trying to make a measurement, I don't want to change what I'm trying to measure. And so here we've seen 2 ways to connect a multimeter. This is in parallel. The other way is to open up that pathway and connect it in series. And depending on what the setting of the multimeter is, depending on whether or not I'm measuring the voltage, there's a little arrow here, whether I'm measuring voltage or if I'm measuring current, I'm be over on this side and I have to move this one over, I have to think about how am I going to insert my multimeter. Because now that I've moved it over to current, if I touch this right here, before we saw it didn't make any difference, now it makes a huge difference to the circuit. So this multimeter will, when I change this dial, I'm changing something about the properties of that multimeter. Something about the resistance of the multimeter depends on where this dial is.